Hi, in this Scribblecast we are going to be looking at factors, prime factorization, and using that in order to determine a lowest common multiple of two or more numbers. To begin with, we need to define what a factor is. A factor is basically a number, I'll write it out, that divides evenly without a remainder into another number. Sorry for my writing. Another number. So for example, if they say, what are the factors of 15? What's a number that divides evenly into 15? Well, 1 divides evenly into it 15 times. I guess 15 would divide evenly into there 1 time. Notice that the factors typically match like that. Another 3. 3 would divide evenly into 15. And how many 3s? It would take 5 of them. So 5 is another factor because it divides evenly into 15. Are there any others? 2? No. 4? No. 8? No. I think those are the ones. So those are factors of 15. Here's some to try. So see if you can list all the factors of these numbers. I'll do the first couple. 9. So it's 1 divides into 9. 3 divides into 9. I guess another 3, but we have that one already, so we won't write it a second time. And 9. So those would be the factors of 9. 16, 1, 2, 4, 8, and 16. There's a list of all the factors of 16. Notice that they often match, eh? So 1 and 16, 1 multiplied by 16, those are factors that multiply to 16. 2 times 8 gives you 16. 4 times 4 gives you 16 as well. You can pause the video maybe and try finding all the factors of those ones. 180 is a nasty one. But pause the video, see if you can find them, then press play and we'll reveal the answers. Okay, you're probably back. Those are what I came up with for the factors of 24 and 180. Okay, so now that we know about factors, now we're going to look at finding prime factorization of a number. In order to figure out prime factorization of a number, you need to know what prime means. And prime basically means a number that only 1 and itself will divide into evenly. So, for example, if I had 8, 8's not prime because it has 1 as a factor and 8, but it also has 2 and 4 as factors. So because it has these extra factors, it's not prime. How about 7? Well, 7, 1 divides into 7, 7 divides into 7. Is there another number that divides evenly into 7? There isn't. I guess you could say 3.5, but that's not an integral number, an integer, so we can't use that. It has to divide evenly with no decimal or no remainder. So 7 would be an example of a prime number. Here's a bunch of other ones. 3 is prime, 5, 7, 11, 13. Looks like they're all odd so far, eh? I guess I should have put in another number there, 2. 2 is also prime because 1 and 2 are its only factors. But I think that's the only even number that would be prime. Next one, 15. Oh no, 15 can't be because 3 and 5 go into that. 17, yeah, that'd be prime. 19, no other numbers other than 1 and 19, that'd be prime. 21, oh no, 3 and 7 go in there, right? That one can't be prime, etc. And you can find some other ones. If you go online, you can look for a list of prime numbers and they give you thousands and thousands of them. Now we know what prime are. Now that can help us determine the prime factorization of a number. And where we're going with this is that we want to find a lowest common multiple of a number, and this helps us do it. So prime factorization means get some things multiplied together where every number that you're multiplying is a prime number, and that all these things here multiply together to give me 24. Let's just see. 2 times 2 is 4, times 2 is 8, times 3, sure enough, that's 24. Find the prime factorization of 12. Okay, well, 12 I know is 3 times 4. Oh, hold on. 4 is not a prime number. Maybe I can break that one down. So instead of writing 4, I'll write 2 times 2. Now all of those numbers are prime numbers, and they all multiply together to give me 12. So this one's not the prime factorization, but this one is. Here's a couple for you to try. Pause the video if you want, and see if you can determine the prime factorization of these two numbers. Then press play and I'll show you how I do it. Okay, tree diagrams are often helpful to do prime factorizations. And basically what you do is you just look for two numbers that multiply together to give you 56. So one of them is 8 times 7. And you could do this a number of different ways. This is just the way I do it. So 8 times 7. Now I check, are they all prime? 7's prime, but 8's not. So I can break 8 down to 4 times 2. And remember, you got to bring that 7 down. So 4 times 2 times 7 is still 56. Are they all prime? 7, yeah. 2, yeah. Well, 4 is not. So I can break 4 down into 2 times 2. Then again, bring down the stuff that you had from up above there. So if I multiply these four numbers together, they should be 56, and it should be every one of them is prime. Each number can only be divided by 1 in itself. That's good. If I multiply them together, I should get 56. 7 times 2 is 14. 14 times 2 is 28. 28 times 2, 56. That one's good. Here's another one, 84. I don't know, maybe 2 times 42. Yeah, that would work. And then 42 is not prime. I can separate that to 6 times 7. Oh, I got to bring this 2 down. So 2 times 6 times 7, that's 84. That's prime. 6 isn't prime. So I can break that one down. 6 can be broken down into 3 times 2. And then I bring these other things down. So 2 times 3 is 6. 6 times 2 is 12. 12 times 7, yeah, that's 84. So this is the prime factorization of 84. Now the purpose for doing these prime factorizations, it's sort of cool doing these tree things, but the purpose of it is for us to be able to like add some fractions. Say if I had 3/56 plus 7/84, when I add them, I know I need to get a common denominator. So I can use prime factorization to get that common denominator that I need. Okay, so common denominator, initially we talk about common multiples, and if it's a least common multiple, if I'm dealing with fractions, you could call that least common denominator. When we're looking at multiples of numbers, what we're looking for is the least common multiple, or the smallest number that two numbers divide into evenly. So if I wanted to find the least common multiple of the numbers 2 and 7, I could write down all the multiples if I wanted to of 2, write all the multiples of 7, and then look for the smallest one that's the same. So 2, 7, 14, 14, there's 14. So those numbers are the same. So that would be my least common multiple of 2 and 7 would be 14. Notice that I also have up here 28 and 28. That's another multiple, but it's not the smallest one. Turns out when you're using fractions, you could use that one, but it's easier if you use the smallest one, which would be 14 in this case. We can try one like 6 and 15. So I write down all the multiples of 6. So 6, 12, 18. Notice all I'm doing here is adding 6 each time. 30, 36, etc. And then 15. 15, 30, oh, that 30 I've seen before. 30's right there and right there. So those two numbers, or that number 30, is my least common multiple between those. Now, you can list these out like this, but it turns out there's an easier way to do it. and that involves using those prime factorizations of numbers. So to determine any lowest common multiple that we use in different things, what we're going to do is write the prime factorization for each number, and then what you do is you just list the factors that appear the greatest number of times, and then those will be my lowest common multiple. Okay, so let's try it. Lowest common multiple in 6 and 8. Again, I could go 6, 12, 18, 24, 30, etc. And then 8, 16, 24. Oh, there's the smallest one. I could use that as my lowest common multiple. That way always works. But watch this other way. And it works, again, all the time. And it's a little easier than having to list all the multiples for numbers. So 6, what we do is we do our tree thing. And we try and find, like they said up top, their prime factorization of the number. Okay, so let's take 6. 6 is the same as 2 times 3. Are these prime numbers? Yes. So this is my prime factorization of 6. Let's do 8. 8. 2 times 4. Oh, no, 4 is not prime. So I can break 4 down into another 2 times 2. So now I have, here's the prime factorization of 6. Here's the prime factorization of 8. Then the instructions up here say, list each factor the greatest number of times that it shows in any one of the prime factorizations. Okay, so let's go down here. Let's look at 2's. So here, let me get a different color. Here I have 1 2. Here I've got 3 2's. So in my lowest common multiple, it says the greatest number of times. So here it only appears once, here it appears 3 times. So in my lowest common multiple, I've got to have 3 2's. And then look around, there's a 3. It appears once here, it doesn't appear anywhere here. You have to write it the greatest number of times. So here, it's appearing once, so that's the greatest number of times that 3 appears. Now, a combination or the product of all of these factors will give me the lowest common multiple. So 2 times 2 is 4, times 2 is 8, times 3 is 24. And if you look up top here, that's what I got there. Let's try another one. 18 and 27. 18, 27 be a whole lot harder doing it this way. 18, 36 plus, what's the next one? 18 times 3, is that 54 or something? Anyway, you see, you can start getting, and to do 27, then 54. Oh, there it is right there. Here, I thought it was going to be hard. Anyway, trust me that when you get some of these numbers, doing it this way might be difficult. So doing it this way with the trees and the prime factorization, way easier. So 18. 18 I can separate into 2 times 9. The 9 I can separate into 3 times 3. Make sure you're bringing the 2 down. So here's my prime factorization of 18. 27, it's 3 times 9. And 9 is the same thing as 3 times 3. Those multiply to 27. There's my prime factorization. So now I look for each factor and the greatest number of times it appears. So here I've got 3 3's. Here I only have 2 3's. This is the greatest one, so I'm using that. 2's, no 2's here. 1 2 there, so I need to use that as part of my lowest common multiple as well. Now I just have to multiply this stuff together. 3 times 3 times 3 is 27, times 2, 54. So the lowest common multiple between 18 and 27 is 54. And if I were adding or subtracting fractions, like say I had 7 over 18 plus 10 over 27, if I needed to get a greatest common or a lowest common denominator between these two, I would pick for each one 54. So it's the lowest common multiple between those two numbers. If I'm looking for a lowest common denominator, that would be the exact same number. All right, hopefully that helps. We've just quickly then gone through looking at what factors are. We've looked at prime factorization and what prime numbers are. And then we've also looked at lowest common multiple and how to determine that. Okay, hopefully that helps. Now try a bunch of questions.